Now let's talk about the classification of matter. Matter are classified into two categories, pure substances and mixtures. A pure substance is a single matter that cannot be separated into other kinds of matter by physical means. Yeah. In a simpler way, a pure substance is one thing. There's only one thing in the sample. Then that sample is a pure substance. Examples here like copper, water, carbon dioxide. A pure substance always has a definite and constant composition. For example, water. Regardless where you get a water sample from, the composition is always the same. Mixture is a physical combination of two or more pure substances. Again, in a simpler way, it is just a mixture of more than one thing. In the mixture, each component in the mixture will retain its own chemical identity and property. Salt water, ice cream, salt water, you have salt and water. Salt will taste salty regardless if it is mixed with water or not. A mixture has variable composition. Okay, a salt water mixture, depending how much salt you will put into water, the composition will be different. Like ice cream as well, depending on who is making it, what kinds of formula they're using, the composition of ice creams could be different. Now let's focus on the mixtures. There are actually two kinds of mixtures. The first kind is called homogeneous mixture. A homogeneous mixture contains only one visibly distinct phase. When you look at it, it is uniform, as evenly distributed throughout. So usually you cannot tell by looking at it if it is a mixture or a pure substance. An example here will be a salt water solution. Okay, by looking at the solution, there's no way you can tell if you have salt in it or not. So you cannot tell if it is a mixture or if it is pure water. Heterogeneous mixture. A heterogeneous mixture contains different phases in the sample. When you look at it, you can tell there are different things in it. The example presented here will be a chocolate chip cookies. So when you look at a cookie, you can see, okay, there's chocolate, there's something else. So far, this is what has been covered in the classification of matter. We talked about matter. Under matter, we have pure substance and a mixture. And the mixture, we talked about homogeneous mixture and heterogeneous mixture. Okay, a quick concept check. So let's see. In the following given examples, let's identify each one of them as a pure substance or homogeneous or heterogeneous mixture. Pure water. Well, pure water. There's only water in it. It's pure, so it is a pure substance. Gasoline. Well, gasoline, if you don't know it, we cannot blame you. Gasoline, as a matter of fact, is a mixture. There are different substances in gasoline. If you know that, now you will have to decide, is it a homogeneous mixture or heterogeneous mixture? Well, when you look at gasoline, it is one phase only, uniform. The composition of a gasoline sample, whether it's on the top or at the bottom or in the middle of the gasoline sample, they have the same composition. So the distribution of different components in the mixture is uniform. So gasoline is a homogeneous mixture. Pure air, or the word pure in pure air is a little confusing. All right. We all know air has different gases in it. In the air, we have oxygen, we have nitrogen, we have carbon dioxide, water vapor. So air is a mixture. A pure air, the word pure here is different from the pure substance. The pure here, the pure here means it is free of pollution. So pure air is a homogeneous mixture as well. Copper metal is a pure substance. That is easy. Salt and pepper seasoning. Well, salt and pepper is a mixture. You look at the sample, you can see there are black pepper or white pepper and there are salt particles. So it is a heterogeneous mixture. Again, this is what have been covered. We have been focusing on the mixture side. Now let's move back, talk about pure substances. There are two kinds of pure substances, elements and compounds. An element is a pure substance that cannot be broken down into simpler ones by chemical means. Chemical means usually include chemical reaction, electric current, heat, and light. Examples here, gold, silver, oxygen, okay, copper, countless. Compounds are another example, another category under pure substance. A compound is a pure substance that can be broken down into simpler ones by chemical means. The examples presented here are water, carbon dioxide, ammonia. Water is formed by combining oxygen and hydrogen. However, when hydrogen combines with oxygen to form water, the water behaves totally different from either hydrogen or oxygen. So a pure substance like water is called a compound because if you use some chemical means such as electricity, water can be broken down back into hydrogen and oxygen. So water is a compound. All right, now we have completed the whole flow chart of the classification of matter. Under matter, we have pure substance and mixture. Under mixture, we have homogeneous mixture and heterogeneous mixture. Now under pure substance, we have element and compound. Before ending this lecture, let's discuss a little more about the difference between compounds and mixtures. We're going to use water as example of compound and a mixture of hydrogen and oxygen gases as example of mixture. The reason I picked these two is because in either case, there are hydrogen and oxygen in the sample. Compounds have properties different from those of the substances that are combined to form the compound. Okay, let's look at water. Water is formed by combining hydrogen and oxygen. However, once the water is formed from the two, water will behave totally different from either hydrogen or oxygen. Hydrogen is a gas, oxygen is a gas, but water is a liquid. Well, talking about a mixture, in the mixture of hydrogen and oxygen, either hydrogen or oxygen will behave as itself. Okay, it retains its own property. Okay, it has nothing to do whether the other component is there or not. talking about the properties of water compound and the mixture of hydrogen and oxygen. Okay, if you start a match with a flame and you put the match into water, the flame will be put out. However, if you start a match with a flame and you put it into the mixture of hydrogen and oxygen, it will explode. Compounds have a definite composition. Compound water, regardless where you get it, how you get it, all the composition will be the same. 2 hydrogen and 1 oxygen combine to form a water molecule. Mixtures, however, a mixture of hydrogen and oxygen, depending on how much hydrogen or oxygen you use, the mixture could have different composition. Physical methods are enough to separate a mixture. Okay, in the case of hydrogen and oxygen mixture, if you control the temperature and the pressure correctly, one of the two may become a liquid while the other one will still be a gas. By doing that, the two can be separated. But you cannot separate the oxygen and hydrogen in water in this way. In order to break H2O water, in order to break that down into hydrogen and oxygen, hydrogen chemical means have to be used.